All right, guys, in this video, we're going to solve absolute value inequalities, okay? The process is not totally unlike solving absolute value equations, okay? But it is going to be a little different because the inequality symbol is going to affect our process a little bit, okay? So here we've got a pretty simple absolute value inequality. The absolute value of 2x plus 1 is greater than 5, okay? So when we're solving absolute value inequalities, the first thing we want to do is, just like with the equations, is we want to isolate the absolute value expression on one side, okay? Now, when we were solving absolute value equations, we kind of did a case 1, case 2 kind of mindset, all right? So we have to, it's a similar mindset, but it is a little bit different. So what we want to do here, we're going to set up a compound inequality, and it's totally based around what the inequality symbol is, okay? So because this is greater than, it's going to lead us in one very specific direction, okay? If this were less than, then it would be a different direction, okay? So before I go through what the compound inequality is going to be, let's think about this problem here, okay? So let's replace 2x plus 1 with a number like 0, for example. So this would be the absolute value of 0 is greater than 5. Well, that's not a true statement, okay? So 0 won't work here, okay? If I want, let's say I wanted to replace 2x plus 1 with 6, okay? Well, 6, the absolute value of that is 6, and 6 is greater than 5, okay? So I know I need a number that's going to be bigger than 5 here, okay, to replace for the entire expression 2x plus 1. I'm not just talking about replacing x with 6. I'm replacing the whole expression with 6, okay? Well, what if I replace this whole expression 2x plus 1 with a negative 6? Well, that's also going to be true because the absolute value of negative 6 is positive 6, and then 6 is still greater than 5, okay? So that tells me a little something about what my compound inequality is going to be, all right? You can memorize what I'm about to show you, or you can kind of conceptualize and think about what kind of numbers need to be in here to make this inequality true, okay? So what I just said is a number that's bigger than positive 5 will work, a number like 6 or a number like 7 for the entire expression. Or a number that's smaller than negative 5 will also work. A number like negative 6, a number like negative 20, replacing for the entire expression here will work, okay? So conceptualize that, and that's going to help you remember the rules we're about to go through, okay? So if you've got a less than sign here, so if the absolute value of some expression, in this case x, is less than some value a, okay? A could be 5, a could be anything, all right? Then I'm going to set up what I kind of call a between inequality, where x is going to be between the negative version of this, negative a, and the positive version of this, positive a. Okay, we're assuming that a is a positive number here. The absolute value of x can't be less than a negative number. It can't happen, okay, because the absolute value of x is always going to be positive. Okay, so we're assuming a is positive. Okay, so if the absolute value of x is less than a, then this will be the inequality, the compound inequality that I set up. Same thing applies, just, if we change this to less than or equal to, okay, it doesn't change anything. The process is still going to be the same. The only difference is the or equal to would have to be included here, okay? Now, in a problem like we're dealing with here, absolute value of 2x plus 1 is greater than 5, then remember I said numbers smaller than negative 5 would work, and numbers larger than positive 5 would work. So I'm actually going to write a compound inequality like this. X has to be smaller than the negative version of a, okay, and then x has to be greater than the positive version of a. Just like 2x plus 1 could be negative 6 here, that will work, and 2x plus 1 here could be positive 6, that would also work, okay? Same thing if the or equal to is added, it doesn't change anything. We're still going to have that or kind of compound inequality where x is smaller than the negative version of what's isolated over here, and where x is greater than the positive version of that. Again, if this value is negative, then our situation is going to change, okay? And you need to think about what could happen there, all right? So let's solve this absolute value inequality here, okay? So step 1's already done. The absolute value is already isolated. This is a greater than, so I'm going to use this kind of setup right here, okay? So I'm going to say x is less than, 2x plus 1 is less than a negative 5, or I'm going to use this part next, 2x plus 1 is greater than a positive 5, all right? So now these are two pretty simple little inequalities here that I can solve. I'm going to subtract 1 from both sides. Okay, so that gives me 2x is less than negative 6 on this part. Over here, I get 2x is greater than 4. And now I'm going to divide both sides by 2. So my solution set here is going to be x is less than negative 3 or x is greater than 2. All right, so that's the solution for this absolute value inequality. Okay, so if you were to plug in some number smaller than negative 3 into our original inequality, you would see that that solution works. Okay, negative 3 doesn't work because then I get 5 in here, negative 5, which gives me the absolute value of that being positive 5. So 5 is not greater than 5. Okay, if I plug in 2 here, 2 times 2 is 4, 4 plus 1 is 5. Well, 5 is not greater than 5. So 2 and negative 3 aren't solutions, but they do kind of set our range of solutions. Smaller than negative 3, but not including negative 3. Greater than 2, but not including 2. All right? So I'm going to skip down here. I want to do one of these practice problems with you. We're going to do number 9 here. I wanted to do a less than problem with you. All right? So let's isolate first. So I'm going to subtract 4 from both sides. Okay? Now that it's isolated, I need to read this inequality symbol. It's less than, okay? So that means 6y plus 2 has to be between negative 18 and positive 18, okay? So if 6y plus 2 is 0, it's going to work. If 6y plus 2 is negative 17, it's going to work, okay? But it can't be to the left of negative 18. It can't be negative 19. It can't be negative 20, okay? Because then we wouldn't have a solution. And it can't be bigger than 18 as well. So that's why we've got this set up here, all right? Subtract 2 from both sides, or all parts, excuse me. Divide all parts by 6, okay? And negative 20 divided by 6 simplifies to negative 10/3. And 16 divided by 6 simplifies to 8/3, all right? So my solution set here is the values from negative 10/3 to positive 8/3, and we say inclusive, because it includes both of those values, negative 10/3 and 8/3, all right? So that's the process you're going to use to solve absolute value inequalities.